rebuild the land and maintain a variety of different coastal habitats, such as wetlands, barrier islands, ridges, and marshes. And organisms that live in dynamic coastal systems like this are very tolerant to change, but this process still causes changes within the ecosystem, and depositing large quantities of sand inevitably will destroy some organisms. So while these efforts claim to increase habitat and benefit wildlife in general, more studies need to be conducted post-restoration processes to assess the long-term effects, specifically regarding nest survival. So the goal of this project was to determine the effect of beach restoration on nest survival in these three focal species, the least tern, Wilson's plover, and common nighthawk. And these species are similar in their nest site selection and ground nesting behaviors, but they differ in their degree of sociality and exist along a gradient from solitary to colonial. So this study was done on the coast of Louisiana, and here you can see on this map that we have 3 restored sites and 3 unrestored sites that were monitored every 3 to 5 days from April to August. And we recorded the species, nest site, nest coordinates, the status of nests on each visit, and the ultimate nest fate. So daily nest survival estimates of each species were calculated using the RMark package in R, and we excluded any unknown fates from the analysis. And possible candidate nest survival models included the covariates listed on the slide, and were compared using AIC scores corrected for a small sample size. Nest initiation date was not selected in any of the top models. So first we have Wilson's plover. So the best fit model for Wilson's plover was an interaction between year and restoration status and an independent effect of region. And overall, you can see, I don't know if you can see my cursor, but overall there's a gradual increase in restored daily nest survival from 2015 to 2019. And overall, daily nest survival was greater in restored sites than in unrestored sites. And I just want to point out that the confidence intervals are pretty large because of a small sample size. So for example, in 2015, 9 nests were monitored in restored sites in the Southeast and 3 in unrestored. So that's not really something we can control, but those are the nests that we monitored. So I'll move on. So here is just a closer look at the different fate proportions for each site, well, for each region, and separated by restoration and non-restored. And I also included unknown fates in these graphs just to give a more complete picture of how many nests were available. So it's important to note here that the decreases in unrestored sites in 2017 and 2019 that we saw in the nest survival estimates correlate with nest loss due to coastal floods and storm events. So in the Southeast Louisiana 2017, 50% of nests monitored in April were lost to coastal flooding, and they all happen to be at the unrestored site. So 100% of those nests were lost. In 2017 in Southwest Louisiana, 100% of nests that were monitored in June were lost to Tropical Storm Cindy. And in 2019 in the Southwest, about 1/3 of the nests were lost to coastal flooding between May and June. And all Wilson's plovers that year nested on unrestored sites. So we see that there's no nests up here at the top. And all of the storm data that I'm referencing was taken from National Oceanic and Atmospheric Association in the storm events database. It's also important to note that the majority of Southwest Louisiana is unrestored. and the majority of Southeast Louisiana is restored habitat. So the nest site selection is reflective sort of the habitat available. I ran some preliminary models, but I haven't finished fully interpreting them all, but those results will be included in a future paper. Overall, it looks like there are just more nests. This chart down here just shows like the total nests for each site or each region and restoration status. So there are just overall more nests where there is higher area. So for lease turn, the best fit model was a three-way interaction among year, restoration status, and region. And unrestored survival was higher in the Southeast. You can see here in the yellow, but then lease turn for some reason stopped nesting in unrestored sites after 2017. In Southeast Louisiana in 2017, only 5 nests were found in unrestored sites. And in 2019 in the Southwest, over here in the green, only 3 nests were found. So the confidence intervals again are very large. And future analyses for lease turn specifically, because they're colonial species, we would like to explore colony effects. So that will be the next step for lease turn models. So there is a less clear pattern here, but there are instances of storm events causing large percentage of nest failures and lease turns, particularly Tropical Storm Cindy in 2017 and Hurricane Barry in 2019. So here you can see that in 2017, there were nests lost to washout in the pink. 2017 for the Southwest, 95% of the nests in June were lost to Tropical Storm Cindy. In 2019, 53% of nests were lost in July to Hurricane Barry. And also you can see here that specifically in Southeast Louisiana, in most years, there's very high predation in the restored sites. So that is also notable. And we see the same pattern here with more nests on the sites with more area, not really related to restoration status, at least from the total nest numbers. And so finally, we have common nighthawks, which their best fit model just showed independent effects of year and region. In general, there are just very low numbers for common nighthawk nests that we monitor. There were no nests found or no nests monitored in unrestored sites in the Southeast, and very few nests were found in the restored sites for the Southwest, which explains why the model didn't select any restoration status effects. And that can be seen here more clearly in the fate graph. There's just like a lack of nests in some of the sites. And again, we see the same trend, although Southwest Louisiana overall has way more nighthawk nests, but in general, there's just more nests where there are more habitat. So in summary, the main takeaway is that restored beaches appear to mitigate storm impacts in some species, but increased habitat may also increase the predator population. When storms occurred, for Wilson's plover, when storms occurred, Southwest Louisiana restored sites had higher daily nest survival. When storms didn't occur, for lease turn, Southeast Louisiana unrestored sites had a higher nest survival. And for nighthawks, lower daily nest survival estimates were seen in both regions and years with storms. So that's all I have today. And there's a lot of people to thank. But yeah, I just want to acknowledge my collaborators and my lab, Kaz Taylor's lab, and there are so many technicians over the years, this data, as well as student volunteers. So yeah, I'm happy to take any questions anyone has.
Thank you very much, Kia. Any questions? I don't see any on the chat. We have minutes for a few questions. I have a question. I'm very interested in that you put the Nighthawks in there because I love them. They're not waterbirds, but
Yeah.
I'm just wondering. So you're seeing a very similar effect with them, though, where the storms are they nesting like in the lower elevation, so the storms are really affecting them?
Yeah, I can mostly speak for the Southeast. I don't really work in the Southwest. If Katie Barnes is here, she can speak more to the Southwest. But yeah, in the Southeast, especially one particular site, Elmer's Island, where we see the most nighthawk nests. They're nesting in like the what we call the flats, like Elmer's Flats, the mud flats. So especially in Grand Isle, if there's any small amount of rain, things flood instantly. So I think that has a lot to do with, they're selecting that site, but it does flood a lot. So
they don't benefit that much from restoration if that's what they're selecting.
Right, yeah.
Thank you.
We do have a couple of questions in the chat now. Emily Johnson has asked, how do you plan to add in the effects of colonial nesting for least terns?
That is a good question. I'm still sort of exploring papers to figure that out. If anyone has any advice, that would be great. But yeah, I mean, first I was just gonna start by like mapping all of the nests, maybe separate the time of the season, and then just assign colony numbers, colony IDs, and start there. But yeah, like I said, if anyone has any advice or has experience with that, please contact me because stats is difficult.
Awesome. So we have a few questions actually asking about some more specifics about the restoration. So let's see. Caroline was asking in terms of maybe the age, the time since restoration. And Erica was asking about whether or not maybe they actually are expected to stay high and dry restoration sites.
Yeah, time since restoration is definitely something I've thought about, especially because looking at the data, specifically in lease terns, that like 2017 drop in like all of the unrestored sites. There were no nests after 2017. That was like right after Elmer's Island had a pretty large scale restoration project completed. So that's definitely something I've wondered about. I haven't tested that yet, but that's definitely something that I want to explore, because the jump in numbers right after that was like over 100 plus the normal amount. So, and then as far as restoration sites staying high and dry, as far as what I've read, I think restoration efforts sort of plan to have to like revamp and add more ground, because I mean, if anyone has been watching the news, like Louisiana has just been like hit over and over and over by hurricanes this season, either like directly or just like the effects pre and post a hurricane that doesn't hit directly. But Grand Isle is so far out in the Gulf that they don't really get a break. They just got their power restored like 2 days ago from the hurricane that happened like 2 weeks ago. So there's just so much damage that happens there all the time. Now, whether the companies will continue to, pile sand and maintain the elevation that was there, I'm not sure, but I don't think with the predicted increase in storms, I don't think it will last very long, sadly.
We have time for one more question. There's a question from Ricardo asking if the restored areas are standalone sandbars or they're connected to the mainland. In other words, is it easy for predators to access the sites?
Yeah, they're connected. Well, in some sites, they're connected to the mainland. In the southeast, everything is on a barrier island that people live on, but there is a bridge. So there are definitely predators, coyotes, and even without talking about coyotes, there are ghost crabs that we think could be a major predator in the restored sites. Just sites in general, but in the restored sites, just anecdotally, I've seen a lot of them.
Thank you.
So yeah.
Thank you very much. Thank you very much.
Thank you.
Our next speaker is Olivia Wolford. Kia, can you disconnect so Olivia can connect her?
Yep.
Hi, Olivia. Share
Thanks.
screen for us, please.
Yes. Can everyone see that? Great. Okay. So welcome to my presentation, investigating the sale, purchase, and collection of federal metal bird bands among waterfowl hunters, implications and challenges for water bird data management. And I'm a master's student in the Applied Anthropology program at the University of Maryland.
Olivia,
First,
your sound is not very good. At least it's sort of breaking in and out a little bit.
okay.
Okay.
Let me try something. Are you able to hear me better now?
Yes.
Okay, fantastic. So I wanted to quickly acknowledge Dr. Jennifer Malpass at the USGS Bird Banding Lab. She supervised this research, as well as my advisor at the University of Maryland, Dr. Jen Schaffer. And most of the photos in this presentation are Chelsea Steinbrecher Hoffman's. So the context of my project took place during an internship with the USGS Bird Banding Lab. I know this is something probably many of you are very familiar with or perhaps have worked with in some capacity. But just to give a little bit of background information, it's a scientific program that's been going on for over 100 years, banding and tracking migratory birds. Every year they mail out about 1 million bands to affiliated banders in the US and Canada, and they receive about 100,000 reports from people who have encountered the bands every year. The reporting process has changed a lot since its inception, originally being a mail-in process, then moving to a phone call-in process, and now it's done completely online, which allows for a lot more data to come in and allows for a lot more information to be collected. So in the beginning of working with the bird banding lab, I really wanted to see what kind of problem or issue my skill set as a social scientist and anthropologist could be of some use to addressing. So something that came up very early on is some reporting issues that have been happening for the last few years. So these include previously reported bands from birds that were listed as dead, being reported as if they were just shot or harvested. Also, bands that had never been reported being reported with incorrect information. So this could be something like a bird that, it was reported in an area where that just would almost be impossible for that bird to be there at that time, or a bird of a really advanced age that also would just not be probable. So this is something that is always happening. People find bands from a relative, they buy them at a garage sale, and want to report them and get a certificate, but they realized it was happening at a much higher volume, and they were able to start kind of tying this to people buying and selling bands, particularly online. So in light of this, they created a whole new way for people to report that they had bought it on eBay. When you go to report, you can just click eBay. And while they hope this would solve the problem, it hasn't. And whenever they have these reports that show up as something that is unlikely, a staff member has to manually evaluate that, reach out to the reporter, and try to get the most accurate data possible. So it becomes a very time-consuming issue. With all of that in mind, my research goals for this project were to understand the motivations of those selling and buying the bands, how that impacts the way that they're reporting these, and how an emphasis on bands has become a larger part of waterfowl hunting culture. So in getting orientated with my research, I found that there was not a lot of literature on North American hunting culture. So I took kind of an interdisciplinary approach, thinking about the hunting-focused model of wildlife conservation in the US, community science, since this essentially is a really large-scale community science operation, and then also the role of trophy culture in the motivations that hunters have for reporting. So waterfowl hunters comprise over 90% of the reports made to the bird banding lab. They're kind of uniquely situated to be up close to bands and really get an accurate read on the serial number. And for quite a while, they've been something that many hunters have collected and often display in lanyards, such as this, a call lanyard that they take hunting or maybe display in their home. As I was getting started with this project, I was really interested to kind of investigate how people were talking about or representing bands in waterfowl hunting culture. So online, it's become something that is, a really cherished thing. Here you can see a wedding band made in the style of a duck band. You can also see a tattoo where someone has tattooed the likeness of bands on a call lanyard. So this was a world I just didn't know much about. So it's been really interesting to kind of see the way it's being represented online. I also wanted to get onto eBay and take the time to really see these different listings and see what sellers were trying to emphasize about the bands, how that impacted the price, things like that. So here you can see one listing that I found, and the seller is saying this was a band that had never been reported. They reported it and are including the certificate to verify that it's not a fake band. And they're saying, I sell all the real deal, not fake things that are flooding eBay. Here you can see a different listing, and in this one, the person is indicating that they had previously hunted the band themselves, not reported it, and will actually give the location information to the person who wins the bid. So just kind of different ways that people are presenting the bands, and to people who may or may not want to report it themselves. So this is kind of the origin of some of the issues happening. So now I'm going to get into a bit of my methodology. So I conducted interviews throughout this summer. I work in qualitative methods, so I knew this was going to be some of the most important data collection that I did. I interviewed 7 staff at the bird banding lab just to get a better sense of their experiences with this issue. I interviewed band sellers, which I actually contacted directly through eBay, but they were definitely the toughest group to contact. And then also 11 hunters, which I found mainly through joining waterfowl Facebook hunting groups, and then recruiting by giving some information about my project. I did semi-structured interviews, which means I had a list of questions, but I let the interviews kind of go wherever the participant wanted them to. And they were usually about 30 minutes to, I think I had one that was 2 hours. So it really varied. I also did a survey using Qualtrics. It had 25 questions. Many of them were open-ended, some multiple choice. And as of September, when I kind of cut it off for my analysis, I had about 200 responses. So in my results evaluating my interviews and the survey data, I wanted to answer these main questions. Why are people buying bands? I kind of developed this idea of collectors versus signalers. Why are people selling the bands? And also, how can the role of bands in hunting culture impact the way people are reporting? And that's kind of, to be useful in trying to solve this problem as well. So for why people are buying bands, something that came up really consistently was the role of social media in changing hunting culture. So in these slides, I'm going to include some quotes that I feel are representative of larger themes that I found. So here you have someone saying a really negative view of social media, and also that, you can see this imagery of big lanyards full of bands, big piles of birds, people overemphasizing the bands. And something that many hunters I talk to express is that even if they've been hunting for 30 years, they might have 3 bands. It's not something that is necessarily super common. So having this imagery of these lanyards, it's giving the idea that this is something that you should aspire to. This is a way to kind of legitimize yourself as a hunter. Excuse me. So that goes into the idea I have of signaling status. So people were citing specifically younger hunters wanting to have this mark of, here's someone said, look how great I am, or saying I got to be like that guy, wanting to emulate these hunters that are more experienced and might have more bands. And that can lead them to potentially buying these bands, purchasing them, and then not wanting to report them, wanting to report them as if it was their own band. There's also collectors. So many people buying bands, they like things that are unique. This could be things that are banned in a particular location, such as Northern Canada. A lot of people are interested in that. Species that are not banded as often, certain types of ducks, or ones that are just really old, ones from the early days of the bird banding lab. So that is another subset of people buying them that aren't displaying them as their own. This was a quote I found really interesting from one of the sellers I talked to. He was discussing how the bands he has that go for the most money are the most recent ones with the most current style. So that's kind of where the money's coming from. I'm gonna skip that one. Why are people selling bands? So it is a relatively small community of people who are selling them. And the sense I got is these are people who are kind of in a community with each other. They're meeting each other at these large hunting shows, and then they're selling, trading back and forth. So most of these people are collectors, and they're doing, they're selling to maintain their own collection. And they're indicating that, the people that they sell to are a really consistent group, and then those people might be selling them on the smaller scale to individuals. Something else that came up a lot with hunters is that there is very much an increased demand. So many of these sellers, they have sold for 10 years, 20 years, but they said recently it's something that is just becoming a lot more common. So here you can see someone was telling me about another seller that he knew who would go to a spot where bluebills were dying from eating a certain type of snail, and he would look through these dead birds for bands just to meet the demand that he had to sell them. Another person, this came up several times, is that hunting guides for waterfowl hunting expeditions, they will have bands, fake or genuine, to put onto birds after, if they're going to retrieve a shot bird, to make people that are their customers happier, that they achieved getting a band. So there is this kind of increased demand for them. Something I asked about was if the sellers reported prior to the sale. So I only was able to talk to 3 hunters. 2 of them said it was very important for them to report, because it indicated to their buyers that they were genuine bands and not fake, which is another emerging problem. Another was indifferent to reporting them, and it's kind of unclear what the larger trend is there, but I think many people want to report it as their own. So a few key takeaways that I have from this is kind of looking at the different reasons that people might be collecting these bands. And I think that the signalers, the people who want to, pass the bands off as their own, they might be more challenging to reach for these accurate data reports because there is a lot of stigma around buying bands. Most of the hunters I talked to, they indicated that they felt they would never buy a band, they would never pass it off as their own because it was an intensely personal thing that tied them to a memory and represented their hunting abilities. So that is kind of one of the key challenges, whereas collectors often want that certificate. They want to know exactly where the bird has come from in an accurate way. Hunting media has been a really big part of this. And also fake bands are kind of an emerging problem. Usually these are less of an issue because people are using fake numbers. So if they're entered into the BBL, that can be automated through their system that it's incorrect. But they are increasing to meet this demand that people have. The last is that sellers are in community with each other. They sell to maintain their collections. And I believe that the best way to kind of address this problem might be to reach out to sellers, really encouraging them to continue to report and to provide the people they're buying to with some information on the most responsible way to proceed after they buy a band. It's not illegal to buy a band. people can display however they want, but just trying to give them the correct information so they're not reporting in a way that is time consuming. And the last takeaway would just be, I was really excited to kind of do an interdisciplinary project. So I hope this is maybe interesting for the way that anthropology and social science can be a part of conservation conversations, and trying to make these processes more efficient to ultimately have that migratory bird data that is so important to conservation. So that is the end of my presentation. Thank you so much.
Thank you, Olivia. It's a very interesting presentation. Things that I had never realized that people were selling and buying bands.
Yeah. Yeah.
Any questions for Olivia? I have a quick question. So what do you know about the demographics of the people that are selling or buying? Is it mostly in the US, and is it certain parts of the country?
It seems to be mostly the US. I did talk to one hunter in Canada, and I think that they get really frustrated with the hunters from the US who are kind of an influx to Canada every hunting season. I interviewed hunters all around the country, so I really think it's something that's happening everywhere, and actually could be happening more in places where there's less waterfowl hunting because people don't have the opportunity to get as many bands, like a place like California, for example. So I didn't get a good read on exactly where everything was happening, but it does seem to be pretty widespread. Yeah, so it is a really interesting thing. I didn't know much about the waterfowl hunting world before this project, so I think there's one question.
Yeah, we've got some questions in the chat box here. Jennifer Arnold asks, do you think this has a potential to become more prevalent? What do you think are the conservation implications, if any? And is there a market for non-game and perhaps protected species, those being reported as found dead as opposed to maybe hunted?
Yeah, I do think it is becoming a more prevalent activity. I do think most of it is centered around goose and duck bands because people are, like, waterfowl hunters are pretty versed in what those bands look like, and some even have an idea of like the way the serial numbers should look. So I think it is mainly with those game species. Also, a kind of emerging problem is the trackers that are on some birds. That is also becoming something people really want to collect. And they've had a problem where people are refusing to like turn them in. Like, they'll report that they have it, but there's no way they can make someone give it back. So I think some of the conservation implications are people, for bands that might be eroded or broken in some way. Usually the BBL asks for people to send them in so that they can be so they can look at them or etch them. And a lot of times people, they're really scared they aren't going to be given back, and so they actually refuse to do that. So I think what I found was the vast majority of hunters really care about providing the data, and they really care about conservation. But the subset of people who are maybe more band motivated, like the signalers, I think that there's going to have to be some kind of creative ways to reach them in order to get the data from them as well.
Great. Jeff Spendelow asked if we think there may be similar things going on with use of auxiliary bands.
I am not sure about that. I mainly focused on the leg bands, but I think potentially people who are very into hunting they're wanting to collect everything, but I don't know if it's happening on the same level of being sold and bought and like counterfeit ones being made. But that's a really interesting question.
And then Kevin Rogers had kind of shared that he had encountered hunters who haven't reported despite having lots and lots of bands because they think they're going to get in trouble for this. Did you also see that from your interviews where that kind of idea was going around?
Yeah, definitely. I think I had a bit of a sample bias in the sense that most of the people willing to talk to me were people who cared a lot about conservation, but they definitely all shared things that had come up in their social media groups, where groups of people in a particular state, if the hunting limits change from one year to another, they might try to have they might say, everyone don't report this year because we don't want this to get lower, the bag limit to get lower, or we don't want them to know where this spot is because other people might steal this spot, or they might shut it down. It might not be entirely legal. Wow. And the BBL tries to mitigate that, but I think that is definitely, unfortunately, a prevalent view that many people have.
Thank you very much, Olivia.
Yes.
Time to go on to our next talk. The next talk is by Haley Arno, and she's going to talk about spatial and temporal distribution patterns of double-crested cormorants and other species in the Penobscot River estuary during river restoration. And Haley is the third in a row student in our session. So go to that website to vote for your favorite students.
Thank you so much, Nellie. I'm just gonna get my presentation up. Sorry for the delay.
Okay.
All right, hi everyone. My name is Hallie Arno. I am a third-year undergraduate at College of the Atlantic in Bar Harbor. And this summer I was working with my mentor, Justin Stevens at Maine Sea Grant, looking at the patterns of cormorants and other important species in the Penobscot River to try to answer some management questions. So a lot of this data was collected by NOAA Fisheries, and I'm really excited to be able to be part of this project. So here we are, we're in Maine on the Penobscot River on the northeast coast of the United States. The Penobscot River is the largest water basin in Maine. So you can see a picture of Maine on the left. This is the Penobscot River. And since it's the largest in Maine, it also has a lot of important species, and it's culturally and historically important as well to the state and the indigenous people that are here. It also has a lot of important species, both economically and culturally. So we have things like alewives and Atlantic salmon. And that's part of the impetus for why there was a really big restoration project that happened here beginning in 2011. One of the biggest projects for that restoration was the dam removal. So here on the right is a picture of one of the many dams in the Penobscot being removed. Other parts of that restoration project included pollution mitigation, because there were a lot of mills here previously, as well as salmon, Atlantic salmon restoration through hatchery work. So here, this is a graph of historic Gulf of Maine salmon populations, and you can see the Penobscot River up until even before restoration of the rivers had almost all of the Atlantic salmon in the Gulf of Maine. So the Gulf of Maine distinct population of segment of Atlantic salmon is an endangered species, so it's protected, which means that restoration is really important because numbers, as you can see, were declining pre-restoration, and almost all of these salmon are in the Penobscot. So that is why it was such a priority for restoration. But when restoration happened, finally, it was led by Natural Resources Council of Maine, and they really wanted to have a multi-species approach. So a lot of salmon restoration projects, as you might know, just focus on having salmon from hatcheries and putting salmon in, and a lot of them haven't been the most successful. So an important aspect of this restoration project is to use a multi-species approach. So they're removing the dams, reducing pollution, as well as monitoring other species that might be predators or prey. There are a lot of theories behind this. For example, prey buffering for salmon. A hypothesis is that if you increase the number of other non-endangered fish, a lot of the birds and seals and other predators will eat the more abundant fish. So that is what I was looking at to see if birds were significant predators of fish, and especially salmon. So to understand this, we really need a lot of monitoring data. So we have a lot of fish data as well as waterfowl data. And we really want to understand how these species are interacting, not only for management of the Penobscot and salmon and other rivers in Maine, but also as a case study for other future restoration projects. So here you can see, here's the Penobscot River again. This little red square in the middle is the estuary, and that's where most of this work was focused. So the way that the data were collected by NOAA Fisheries were a few different ways. There's a transect that collected fish biomass, and that used acoustic radar data to try to understand how many fish are in the river. There's also a visual point transect survey for birds and mammals, and that's most of the data that I will be looking at. Today we're focusing on double-crested cormorants, and I'll tell you why in a minute. But first, here are the number of surveys done, and I just want to emphasize that there's a focus in May and June. That's when almost all of the surveys were done, and it tapers off a bit in the spring and late fall. It's really important to note that this is the nesting times for a lot of these birds, especially cormorants. So we see really high numbers in a lot of these surveys because we're looking at nesting times. Here are some of the results of the birds. So here we have our cormorants, and we only saw double-crested cormorants in the river estuary. And then we have gulls, as you would expect, a lot of ducks. And the reason that we're focusing on cormorants for this presentation is because there are so many. They were the most abundant by far, and they're also potential predators of birds. So here you can see the very top news headline was from just a few days ago, actually. Canada, in Ontario, they just decided that it was legal to hunt cormorants, and that is most likely because people think that they are predators of fish, especially endangered and protected fish and valuable fish. So cormorants have really historically been the enemy of humans and fish. And we're trying to see with science, is that really the case? And a lot of papers are pointing to no, but there are other papers and ideas that say that cormorants might have an effect on fish populations. So you can see in the lower left, this one right here was a paper that found that when cormorants were harassed with something like fireworks or loud noises or blinking lights, salmon survival in the estuary increased. And on the right, this one right here, you can see Ashmole's halo. They found that there was evidence for prey depletion of fish by birds, and other people have found in really large cormorant colonies, there was fish depletion. So that is what we were looking at with this study. So here are overall just the cormorant trends. On the left, you can see the mean cormorants counted per survey annually increased fairly linearly with a significant p-value. On the right, this is just by month, so that's all the data pooled by month. So you can see there are no cormorants seen in March throughout the entire survey. A few in November, but almost all of them were seen in the summer and early fall months. So there's a lot going on in this graph. I'll walk you through it. So the x-axis is the year, and the right axis is the average number of cormorants seen. So all the surveys put together for that month and year, and these lines represent the months. So you can see May is this line with the steepest slope. So we saw the greatest increase of cormorants in the month of May over the course of these surveys, which happened from 2011 to 2019. They're actually ongoing. And you can see that the birds seen in the fall actually have stayed fairly steady. So in the fall months, there wasn't much of a shift in cormorant numbers, and most of the increase annually happened in the spring. We also have fish biomass per survey. So we can see that fish biomass is increasing, likely as a result of restoration efforts and more habitat availability. So that's great news for restoration. But at the same time, interestingly, we also see predators of fish increasing. So bald eagles, which eat both fish and cormorants and just about everything else, have increased over the survey period, as well as we saw, double-crested cormorants. So this is really interesting to see that throughout the whole food chain, there are increases happening because of restoration. And this could suggest that prey availability is not the limiting factor here, but habitat availability is. And when we look at the spatial patterns, we see evidence of that as well. So here is this middle is the Penobscot River. This is the entire extent of the survey. This is the estuary. So it's the ocean here, saltwater, and up here it's just about completely freshwater. And on the left are some man-made structures where cormorants were frequently seen, and on the right are natural structures where cormorants are frequently seen. And you can also see these hotspots popping up on the map, survey after survey after survey, regardless of where fish are. Cormorants are seen at these same spots. So here's a quick animation of where we see cormorants. Here's the survey date on the upper left. And you can see this rookery at Sandy Point. This is where cormorants were nesting, and almost consistently every single survey, just about, we see most of the cormorants there. And then in the fall, they start to wander off a bit and go more up into the river. I just want to note that the survey ended here. at this Bangor Bridge. So part of the increase of cormorants could potentially be cormorants moving downriver, or it could be an actual increase in population. That's something we're wondering about, and we can't tell from this data set. But yeah, as you can see, there's a really strong seasonal pattern into the location of the birds, and as well as a overall temporal pattern where cormorants are increasing over time in the estuary. Here you can see those patterns a little more clearly with them all lined up next to each other. And so that's what the purple is, but we can also see the green is fish biomass. So something that I really want to emphasize on these graphs is that the fish biomass is strong right here at the sort of by Verona Island, no matter where the cormorants are. So whether there are cormorants right there where the fish are, or whether they're all nesting in the rookery, the fish biomass remains fairly consistent as a hotspot in that area. So that suggests that there actually isn't depletion happening from this number of cormorants. And it is a fairly small number of cormorants. I think the peak was close to 200 nesting pairs. So it's not a huge colony. We also found that there was no significant correlation between spatially where fish are and where cormorants are. So that would suggest that cormorants are quite opportunistic and feed where there already is habitat, as opposed to seeking out dense prey, which is good news for fish populations. So we saw that cormorant, bald eagle, and fish populations have all increased over the survey period. So on this whole food chain, restoration has likely helped all of these species, regardless of where they are in the food chain. So that's a really important for management, that the habitat is more of a limiting factor to cormorant abundance as well as fish abundance, more than prey availability. So that's really great news for restoration. And we hope that this data can inform other areas and show that cormorants might not be the enemy if they are in fact opportunistic feeders, as other studies have found. So this restoration has positively impacted all of these species, and increasing predators have not necessarily resulted in a decrease of prey. So all of these species are coexisting, and historically they've all had higher abundance. So we hope that eventually all these species will get to their historic abundance. And in the meantime, we hope that this research will be able to inform restoration efforts and management, and hopefully not result in killing birds, because they do not have an effect on fish populations that we have been able to see. So there are a lot of people involved in the study. I was just responsible for data analysis, but I really want to thank Paul Music, Mike O'Malley, and Christine Lipsky at NOAA, Kate Beard-Tidsdale at UMaine GIS, Lori Leach at UMaine School of Marine Sciences, Jim Hawks and Graham Goulet at NOAA Telemetry for the fish data. And also thanks to John Anderson at College of the Atlantic for helping with the presentation and talking through a lot of these issues. And of course, thanks to my mentor and co-author, Justin Stevens at Maine Sea Grant. And I'm happy to answer questions.
Thank you very much. That was a very interesting presentation. And we're opening it up for questions. And I had a question first. So I'm not sure, maybe you said that and I missed it, but are there counts at the colony as well? And do the counts of the colony reflect the overall counts that you're seeing of the birds in the river?
Yeah, that's a great question. So we do have counts of the colony. I don't have them as a table. Maybe I should have put that in. But we have, the colony has changed a bit over time, and it's increased over time. You can sort of see in these heat maps. But we found more of the colony, most of the variation is between months more than over the entire time series. But that's a great question to look more into.
We have a question from Susan Eldon. Is anybody looking at the cormorant pellets for the diet analysis?
Yeah, actually, so this study didn't look at any pellets, but Blackwell, I believe, in the late 90s, looked at pellets to evaluate diet, and he found that they have a fairly diverse diet. And that would also bring evidence in to suggest that they are opportunistic feeders and not necessarily looking for salmon. So that would mean that prey buffering and an increase of overall fish would help protect salmon populations. So that's a great question. Yeah, thank you.
And we have another asking if there was an increase in populations of any other exclusively piscivorous birds, or did increases in cormorants possibly prevent population increases in other species?
That's a really interesting question. Thank you. I will look into that more. I know there was an increase in bald eagles in the estuary, but we haven't focused on other species as much. So yeah, thank you for that. That's something I'll look into.
Any other questions? Thank you, Hallie, for your presentation.
Thank you.
And it's a little early, but we can move on to the next presentation if Sam is ready to go. The next presentation is by Sam Collins, and she's going to talk about what's in the future for wading birds nesting on marsh islands in New Jersey.
Okay, thank you. Let me just share my screen. Everybody see that okay? Yeah. Okay, so I'm going to be talking about wading birds nesting on some marsh islands in New Jersey. And to give you a little bit of background about wading bird trends, there's been some shifts in nesting abundance and distribution based on aerial surveys that were conducted by the New Jersey Division of Fish and Wildlife between 1976 and 2018. Overall, we've seen some declines in the total number of nesting individuals, which you can see from the graph on the top right. And we've also seen a decrease in the number of active colonies overall, as you can see from the graph on the bottom right. But you can also see that some species are experiencing increases in recent years. Some of the species include the great egrets and snowy egrets. But overall, again, we're seeing some of those declines, and some of those increases might be due to limited colonies in other areas. We're looking into 8 different species of wading birds, and 7 of these species are considered priority species of greatest conservation need. And again, these 8 species are listed below. And I'd like to point out that 3 of these species are listed as state threatened, and that's cattle egret, black-crowned night heron, and yellow-crowned night heron. So our study areas were in the Cape May area of New Jersey. These have prior sediment placement areas, and these prior sediment placement areas are extremely common along navigable waterways. So for example, the New Jersey Intracoastal Waterway, as you can see here, cuts through the middle of the figure. And these areas account for most of the remaining higher elevation marsh habitat within the area. And it's also created, these prior placement sites have created important wading bird nesting habitats. So for example, 98A, B, and C are the areas I'm going to be focusing in on these talks. And those areas are located at the bottom of the figure. So to give you a little bit of background about these study sites, here's a historical image from 1956. And the areas we're focusing on is Sturgeon Island and Gull Island. And you can see here that Sturgeon Island and 2 different areas on Gull Island, which we're calling Gull 1 and Gull 2, had already received sediment placement from some of these dredge operations. You can see more recent imagery on the bottom right. So the left is Gull 1 and Gull 2. And then on the right, the bottom right is Sturgeon Island. So jumping to a more recent image from 2019, you can see that another nesting area on Gull Island formed, which we're calling Gull 3. And this area was a control area for our study. And again, on the bottom right, you can see an aerial image looking from north to south of that nesting area. And this nesting area received placement in the 1990s and became a nesting area in the early 2000s. So a little bit more background on Gull and Sturgeon Island. Based on statewide aerial surveys. The most recent was conducted in 2018. And based on these surveys, gull and sturgeon island colonies support over 27% of all colonial nesting wading birds in the state of New Jersey. Gull Island alone supports the largest concentration of nesting wading birds statewide. So these are very important nesting areas. But you can see there's been some shifts in species diversity. Specifically in 2001, there were more yellow-crowned night herons nesting, especially on Sturgeon Island, and we haven't seen them nesting for the past decade on these islands. But we have seen increases in other species like glossy ibis over the past few years. And in general, we've seen some increases in the number of birds on these islands for some species. And again, this might be a result of fewer suitable nesting colonies statewide. So why is this important? This is imagery of high water predictions for the next 15 years. And you can see our study area, gull and sturgeon in the circled area for 2020 on the left, and a 15-year projection, 2035 on the right. And you can see that these sediment placement areas, or gull and sturgeon nesting areas, are some of the few high marsh areas with the high water predictions. We're also experiencing high rates of marsh edge erosion. It's an important contributor to marsh loss. You can see from these figures that Sturgeon Island has been experiencing high rates of marsh loss, especially on the north and northwest edge of the island, and Gull Island, especially on the northern edges of the island, and also along the west and southern edge of the island. So our study objectives were to understand the colony features and the ecological needs for sensitive wading bird colonies on both Gull and Sturgeon Islands. So we're looking at nest site preferences like vegetation, elevation, specific locations between and within nesting areas. We also want to determine species abundance and distribution within and between nesting seasons. And we want to contribute to those long-term trends conducted by the state looking at species abundance and distribution. We also want to investigate nest success for sensitive nesting wading birds and identify the limiting factors for them at these locations. So we want to start to investigate the relationship between nest survival and some of the habitat features, as well as some of the temporal effects, so within and between nesting seasons. So our methods for monitoring were to conduct weekly site visits at the focal sites. And again, the focal sites were Gull 1 and Gull 2 and Sturgeon Island, and also conduct monthly surveys at our control site, which was Gull 3. We also selected nests randomly for monitoring efforts, and we focused on 4 species that had the greatest abundance at these sites, which were great egrets, snowy egrets, black-crowned night herons, and glossy ibis. We also opportunistically located and monitored nests for little blue herons and tricolored herons. We won't really be talking about them in the talk today because the sample size was so low for those. But whenever we found a nest, we would document the nest location with a handheld GPS accurate to 3 meters. We would record the species. We would measure the nest height above the ground level. We document what was in the nest, so clutch size or brood size, and what the dominant vegetation was directly surrounding each nest. At the end of the season, we went back in with a high accuracy Trimble GPS unit to mark the nesting areas and to collect elevation at those nest sites. In 2020, we implemented game cameras and temperature loggers at select nests. The ones we selected were black-crowned night heron, glossy ibis, snowy egret, and little blue heron. And this was to further assist us with identifying causes of nest loss and looking into attendance rates at these nests. We've conducted some preliminary comparative analyses at this point to assess differences in nest site selection and hatch success between these sites, so between Gull and Sturgeon Island. And we've also done some logistical regression to investigate variables related to hatch success for each island. So here are results from our direct surveys on Sturgeon Island. As you can see, there's a little bit of a delayed arrival from certain species, with great egrets arriving first on the island and snowy egrets and black-crowned night herons arriving a little bit later. And especially in 2020, snowy egrets were a little bit later to arrive on the habitat than in 2019. But overall, it's important to point out we did see a lower total number of nesting birds on the island. And we did see lower numbers overall for most species, but especially lower numbers of glossy ibis during the 2020 season. Looking at Gull Island, again, peak nesting was around May, similar to Sturgeon Island. And unlike Sturgeon Island, we actually saw an increase in the total number of nesting species during peak nesting in May and June. And this was mostly driven, again, dissimilar from Sturgeon Island, there were more glossy ibis nesting on Gull Island in 2020 compared to Sturgeon Island. So there might be some colony exchange between these two sites, and these two sites are very close by, so we expect that is likely occurring. So preliminary analysis from our site comparisons, we investigated hatch success between Gull and Sturgeon Island, and we found that it was significant. Gull Island overall had an 81% hatch success for all species in all years. Sturgeon Island experienced a 64% hatch success. We also found that the nest distance to the edge of the nesting habitat was significantly different between the study areas. The nests on Gull Island were on average 23 meters from the edge of the nesting habitat, whereas on Sturgeon Island, they were approximately 4 meters from the edge of the nesting habitat. And we also wanted to look at if there were any differences in ground elevation at the nest sites, but we didn't find any differences between the two sites for nest ground elevation. So looking at the nesting habitat on Sturgeon Island, we again walked the nesting habitats and we calculated that there was approximately a little over a half an acre of suitable nesting habitat, which mostly consisted of Phragmites australis or common reed and Iva fructescens or marsh elder. And these were primarily in 5 discontinuous patches on the island that were selected by wading birds, as you can see from the figure on the right of where nests were located between the 2 years. We also found smaller patches of Phragmites and Iva throughout the island, as you can see from the figure, but these were rarely selected by the nesting wading birds. We also documented a very large colony of nesting gulls in the adjacent marsh flat, which is primarily consisting of Disticula spicata to the west of the nesting areas. We estimated about 80 to 120 great blackback gulls and about 12 to 25 herring gulls nesting in this area. So Gull Island, we estimated had about 3.5 acres of available nesting habitat. Same vegetation, it was common reed and marsh elder or Phragmites and Iva. And these were in 3 large nesting areas that we discussed earlier, Gull 1, 2, and 3. And all of these were over 0.7 acres. So that's larger than all of the nesting area, the available nesting area on Sturgeon combined. We found from habitat calculations that Gull 3 appears to be experiencing the highest rates of habitat loss. We did observe erosion evident on the north edge of the habitat and close to the mud flat along the south edge of the habitat. So that needs further investigation. We also found nesting gulls were present adjacent to the nesting areas, especially on Gull 1 and Gull 3. But these were primarily herring gulls in these areas. We did see some great blackback gulls nesting on Gull 1 and 3. And we did see a few herring gulls in Gull 2, but not nearly as many great blackbacks as sturgeon. So looking at the results of nest success on Sturgeon Island, we did observe slight differences between the years in overall nest success for the species, 60% in 2019 and 70% in 2020. But this wasn't statistically significant, but what was statistically significant was the interaction of species by year, with black-crowned night herons and great egrets experiencing lower hatch success in 2020, and snowy egrets and glossy ibis experiencing higher nest success in 2020. Looking at Gull Island, we saw the opposite. We saw a decrease in apparent hatch success between years, 87% in 2019 and 2020, and that was significant. But we also found species by year was significant as well, with most species experiencing lower hatch success in 2020, except for snowy egret experiencing higher hatch success. So we wanted to investigate the causes of nest loss, which was very difficult at some of these sites, especially only visiting them on a weekly basis. And the causes of nest loss were primarily based on evidence at the nest site. But again, our game camera footage in 2020 did help us identify avian predation and other causes of nest loss as well. So both sites had a high rate of unknown causes of nest loss. But both sites did have rates of causes of nest loss due to avian predation. It's important to point out, though, we did see abandonment and overwash at sturgeon, and we did not identify that as a cause of nest loss at gull. So looking at overwash on Sturgeon Island, we found 8 nests with evidence of overwash as the cause of nest loss in 2019. So this is mostly eggs that were washed from the nests following a high tide event or rack around or in the nests. So this is 5 great egret nests that failed in mid-April, and then an additional 3 nests from 2 snowy and 1 glossy ibis that failed in late April, early May. And these were following times when the water levels exceeded a meter in elevation, which was higher than the calculated nest elevation at these sites. We didn't observe any signs of nest failure due to overwash during the 2020 season, and we're still looking into that. Looking at avian predation, we saw more avian predation on Sturgeon Island than Gull Island. There were 20 nests that we identified as avian predation as the cause of nest loss on Sturgeon Island and 7 on Gull Island. As mentioned earlier, there are gull colonies present in the marsh flats adjacent to wading bird nesting areas on both islands, but there were more herring gulls nesting on Gull Island, especially at Gull 1, and more great black-backed gulls nesting on Sturgeon Island. We also observed fish crows on both islands, and we did document them depredating unattended nests on sturgeon. We didn't have any documentation of that on gull, but it's likely that that might be occurring as well. We did document interspecific competition at nest sites causing nest loss. Camera footage showed black-crowned night heron, tricolor herons, snowy egrets, and great black-backed gulls at nest sites around the time of nest failure. And the other thing to note, there were double-crested cormorants that were nesting in cedar trees, especially in high concentrations at Gull 1. There were a few lone trees on Gull 2 that hosted a few nests of double-crested cormorants, and there was a high concentration of double-crested cormorants along the northern edge of Gull 3. We didn't observe any on Sturgeon Island, and this is of note, these likely aren't causing directly to nest loss, but these might be contributing to habitat loss for nesting species. So what's next? The U.S. Army Corps Philadelphia District is pioneering some engineering with nature. This is a proving ground for their efforts. The dredging and placement operations for coastal channels is implementing regional sediment management and engineering with nature principles to restore the navigation and keep sediment in the natural system wherever possible. From these efforts, they've progressed from 25% reuse of dredge material before Sandy to 60% reuse of dredge material after Hurricane Sandy. And they're hoping for a goal of 100% use of beneficial use of clean channel sediments throughout coastal New Jersey. So how are we going about doing this? We've kicked off the 7 Mile Island Innovation Laboratory, or as we call SMILE. As you can see from the figure on the right, there's areas where some of these efforts have occurred and some potential areas for implementation. And this area is a proving ground using natural and nature-based features to provide ecological uplift and enhance resilience for ecosystems and coastal communities. It's a test bed to advance and improve dredging techniques and marsh restoration and coastal feature creation techniques throughout coastal New Jersey. And we're using a systems approach and adaptive management to move from these pilot projects to solutions. It's based on an international concept pioneered by the Dutch. And we selected this area because it's a back bay marsh system with shallow bays, sounds, and tidal inlets, and it's bisected by the New Jersey intercoastal waterways. So it's a great opportunity for us to learn about these methods. So we've already implemented some of these on areas on Sturgeon and Gull Island. And within these areas, we've placed unconfined marsh sediment to create nesting habitat for wading birds. So on the top right figure is the direct placement on the north end of Sturgeon Island. And then on the bottom is placement on the south end of Gull Island. So these are located away from the current nesting areas to test and see how these work, with the target elevation at 3.5 feet NAVD 88, which is the shrub elevation benchmark. So we're trying to target that marsh elder, and we're also keeping it above mean high water benchmarks and the frequent storm flooding elevation. We've also done some, with these efforts, some in-water placements to create sandy marsh edge protection and create additional habitat for other species, and tidal creek outflows to expand those intertidal flats and build intertidal shallows. So we're benefiting other species as well. So in conclusion, from the study, we found lower overall nest success on Sturgeon Island compared to Gull Island. Again, the statistical analysis supported differences between those nesting areas, and there were also differences in nest success for wading birds between years at both sites. There was evidence of avian predation at both locations, more so at Sturgeon Island, and overwash was only observed at Sturgeon Island. Sturgeon Island had smaller nesting areas, and nests were closer to the edge of the habitat than nests monitored on Gull, which leaves them more vulnerable to avian nest predators like fish crows, herring gulls, and great blackback gulls. And there's more competition for limited space on Sturgeon Island. And finally, we're conducting innovative methods to beneficially use dredge materials during routine operations that might create additional habitat for sensitive nesting wading birds to enhance reproductive success and sustain these islands as suitable areas in the future. Thank you for your attention. I'll take any questions you may have.
Thank you, Sam. And we have time for a couple of questions. I had a question. So why do you think that there was a movement of the ibises? It seems like they were the ones sort of made up the difference between the 2 years. Were there changes? Do they nest lower down than the other birds? Or were there changes?
A lot of it has to do with changes in the availability of suitable habitat for glossy ibis. So I'm sure there's areas outside of the state that where they were nesting previously have diminished, or they're not suitable anymore, and they're moving into areas around here. But again, that needs further investigation, and that's something we're trying to figure out.
Was there any construction between the 2 years, or any other major changes in the availability of habitat, or was it pretty similar on both islands?
We chose those 3 focal areas because it was pretty similar. It looks like Sturgeon in the 2 areas and Gull received sediment around the same time in the mid-1900s. Again, Gull 3 received, formed a little bit more recently than the other areas, but those are the only areas we've been investigating so far. But again, the state has been doing the aerial survey, so I'm sure they know more about what's going on statewide as far as changes in the colonies and formations of new ones.
I see a question in the chat.
Yeah, Pam has asked, are there human disturbances at these sites?
There's pretty limited human disturbance. Again, it is right by the intercoastal waterway. You can see that kind of cutting right in between Gull and Sturgeon Islands. So there is boat traffic, but as far as people getting off their boats onto these islands, I would expect it's not very great. We had game cameras up and everything monitoring these nesting colonies, and we didn't see any evidence of people disturbing them or anything like that. So I think most of it would probably be avian predation, and we haven't seen any evidence of mammalian predation on the islands as well.
We have time for one more question.
Yeah, so Lindsay has asked, as the habitat work's being done, is lower marsh being filled in? And she's wondering about the permitting implications for that sort of work.
Yeah, so the area on Sturgeon that you saw getting filled in there, that was actually mostly low marsh areas. So that's on the north side, as we saw from some of the first figures I showed. That area is experiencing high rates of erosion, and it's also primarily alterniflora areas that we're filling in. So it's kind of a pioneering to see if we can build that elevation, if it'll sustain, or how much it'll take to create that habitat and make it so that we can promote IVA and frag and make it a suitable nesting area. But they have done lower marsh areas as this is building to high marsh. So this is building to 3.5 foot elevation. But we've also done some other innovative techniques with the 7 Mile Innovation Lab of building low thin layer placements and other techniques to target other species like shorebirds, foraging, and things like that. So we're testing different methods. Yeah.
All right, thank you, Samantha.
Okay,
and our next speaker, our next presentation is by Joanna Berger. The title is Relationship Between Metal Levels in Shorebirds and Horseshoe Crab Eggs During Migration. Joanna, your microphone is still muted too.
We're getting there. What are you trying to press?
I'm trying to get it to go to the full screen. Say hello.
We're trying to get this up, but
I do have a copy on my computer if you want me to try to project it from mine.
no, it's.
Are you seeing it now?
Okay, it should
Yeah,
be.
but the side is cutting off. The left side is cutting off.
It's still cutting off.
Yes.
On my screen, it's full. All right, Nellie, put up yours. I was using.
Up here.
I was using.
Oh, I see.
I don't know why it's cut off.
Yeah,
It's
I'm not sure if, let me share. Can you unshare and see if mine will look better?
Yeah. Wonder why it did that.
Mine is not starting.
I shared the screen.
No, here we go. Don't know what it just did. Okay. Okay. Let me share screen.
We checked this yesterday and it was perfect.
Yep, it was.
But now it's black.
Okay.
Is it still off?
Mine is on, and I think I can see it. Can everybody see it? Okay.
I can see it.
Okay, great. Hi, everybody. Sorry that this happened. I had been using the program on my other computer, and the screen just died on the other computer. So we're trying to use a new computer. Anyway, it's wonderful to see everybody. I'm going to talk about mercury levels in Delaware Bay, and the usual thing people think about is the level of metals in prey is reflected in the metal levels in the organisms themselves. This is the basis of a lot of what we do, but as Peter was talking about this morning, it's sometimes difficult to really show a one-to-one relationship because the organisms like herons and egrets and ibises and shorebirds are eating many different kinds of prey, many different sizes, and it's difficult to put them together. Next. I guess this will work, Nellie, if you just move it.
Yep.
Okay, basically, we've been exploring the levels of mercury in shorebirds in their prey for a number of years. We've also been looking at it in many different species in New Jersey for shorebirds since the 1990s. But the interesting thing about looking at shorebird metal levels, particularly in Delaware Bay, where we've been working for a number of years, is that the shorebirds come in, they're only there for a very short period of time, 2 to 3 weeks for each individual. The whole period is a little bit less than a month, but individuals are there for only about 2 to 3 weeks. During that time, they eat almost exclusively crab eggs, as Nellie showed years ago when she was working there. Next. Basically, the food chain for Delaware Bay can sort of be shown on the bottom, on the left here, where algae, of course, in the usual base of the food chain occurs, but the important thing are horseshoe crabs and their eggs. And their eggs are eaten by many, many different organisms at different times of the year. Small fish eat them, larger fish eat them. So eventually the horseshoe crab eggs make their way actually into people because the people are eating the bluefish and the weakfish, striped bass from the bay. But more importantly, in this time period in May, they're eaten almost exclusively by laughing gulls and shorebirds. The laughing gulls, of course, are breeding over in the colonies in across the bay in Stone Harbor, which Lisa was just talking about. Next. The species we're going to talk about are the main species that move through the bay, although some 16 or 17 move through at different times, different shorebirds. Are red knots, and the horseshoe crab is shown here, turnstones, and of course semis and sanderlings. Next. So the objectives of our study was to examine the temporal patterns in mercury levels in horseshoe crab eggs and in other metals and in shorebirds over time, and to examine the relationship between mercury levels and other metals in the blood of shorebirds and the levels in horseshoe crab eggs, since eggs are their primary prey. Next. So we've just seen a map similar to this, but this basically shows where we were working in Delaware Bay in the United States, which looks a little crunched there, but nonetheless, you'll get an idea of where we're talking about. Next. So the conceptual model for what we were dealing with here basically was to look at the levels of metal in different nodes on the food chain. And these are some data I'm not going to talk about very much here, but it shows you the mean levels of mercury as it moves up through the food chain and goes through crab eggs into baitfish, young bluefish, eventually into terns that are nesting. And you can see the usual magnification as the metal levels move up the food chain. Next. So migrating shorebirds depend upon horseshoe crab eggs when they move through Delaware Bay. It's a location where, in fact, there's real clear dependence on the eggs. And if you look at the picture on the left, you'll see the horseshoe crab eggs. And sometimes in the early 1970s, 1980s, the beach was literally strewn green with those horseshoe crab eggs. Now, of course, because of overfishing of horseshoe crabs for a number of reasons, the eggs have declined and there's been a real shortage of eggs. And that has contributed, we believe, to the declines in the numbers of red knots and other shorebirds. So the knots, while they're in Delaware Bay in a period of 2 to 3 weeks, must basically almost double their weight. And that's a short period of time. If you imagine yourself doubling your weight in 2 to 3 weeks, much less 2 to 3 years, it would be a serious problem. On the right, you see Larry Niles, who I've worked with on this project for a number of years. And in his left hand, he's showing a bird that's been there for a while, and you can see how fat it is. And the one on his right hand has just arrived and is relatively weak. The picture in the middle, of course, are red knight knots. Next. I keep going to want to do it. So basically the methods are what you might think: monitor, collect, and analyze. We have to collect samples, we freeze them for later analysis. Then they're digested appropriately for the type of the sample, which depends upon whether it's eggs or feathers or whatever, and use a PerkinElmer and a dedicated mercury analyzer. I'm shown there this summer collecting horseshoe crab eggs. I had to get permission from the governor to actually go do it at the governor's office because he closed all the parks and the beaches, and I'm appropriately attired with a mask to collect the eggs. And Chris in the lab is doing the analysis on the PerkinElmer machine. So what we were really interested in is how are metal levels changing over time period, and can you see changes? So this is the temporal pattern of mercury in horseshoe crab eggs, and you can see that generally mercury has declined slightly, but there's a large variation. Now, there's a lot of reasons for that. Horseshoe crab eggs, of course, you're talking about something that's small and is largely water. You're talking about Delaware Bay, where there's a lot of different sources of pollution. And we're talking about eggs that are gathered over a short period of time. So that although there is a slight decline from 1993 to present, it's not really very great. Next. So if we look at differences in the patterns of mercury and feathers of shorebirds, you basically need to remember two things. Feathers are reflecting the metal levels at the time they were formed. So in this case, the levels reflect the birds when the birds were in their southern or wintering range, because that's where they reformed the breast feathers. Nonetheless, you might expect that there might be some differences. And basically from 1991 to 2011, 2012, and we have all the different years, but I haven't shown them all. Basically in sanderlings for mercury, for example, the metal levels declined. In red knots, they did not decline. There was a slight decline, but it was not very great. In semi-palmated sandpipers, there was no significant change. We collected samples from 2017, 2018, and 19 rather, but we couldn't analyze any of them, of course, because we had them all partly digested and ready to be analyzed when COVID hit. And I don't know about people elsewhere, but our university was completely closed down for several months, and now only some people are allowed back in. So we're waiting to see what has happened recently. But this basically shows the trends in what the birds have been exposed to on the wintering grounds when they arrive in Delaware Bay. The important thing that we were most interested in was looking at the relationship between different metal levels in horseshoe crab eggs and in the blood of shorebirds, because while they are on Delaware Bay, the shorebirds are eating almost entirely the eggs of horseshoe crabs. So it's really kind of interesting. And I was really surprised, as Peter noticed before, it's really interesting when data actually come out. But the interesting thing here is the shorebirds are eating almost entirely horseshoe crab eggs. And so you might expect that there'd be a better correlation between the prey that the species is eating and the blood, because of course they're eating it and it goes into the blood. So if you look at the relationships for cadmium, mercury, and lead, it's very, very close to exactly what is in the horseshoe crab eggs. Of course, we're looking at a different level, of course, because there's bioamplification, biomagnification. So the amount that they're getting in the blood is going to be greater than the amount that's in the eggs of the shorebirds. But it's pretty close and it's pretty interesting. The one that's different is selenium. They're concentrating, the shorebirds are concentrating somehow more selenium in their blood than is in the shorebird eggs. So there are, however, if you don't look at it logarithmically, there are differences in the species and how much they're amplifying if you look at mercury. So if you look at horseshoe crab eggs, and of course their pools, you know, obviously the horseshoe crab eggs are very small. And so we pool the eggs from clutches. So it's a pooled sample of eggs. But if you nonetheless, if you look at the metal levels, you see that within shorebirds, there are some significant differences even in mercury. So the horseshoe crab eggs and knots and sanderlings and semis are pretty even, but it starts increasing in semis, in sanderlings rather, and in turnstones. It's almost 3 times as high in the blood of turnstones as in the horseshoe crab eggs. Now, so the question that we're really interested in, the reason that we were collecting samples in 2019 through 2020 is to try to figure out why the differences, because the knots, the semis, and the turnstones are feeding almost entirely on Delaware Bay. If there's a problem with food on Delaware Bay, they sometimes will go to the coast, but that doesn't happen very often. The sanderlings feed mainly on Delaware Bay as well, but they may go to the Atlantic. Here we show what it is when the horseshoe crabs come up to spawn in the, usually there's a greater spawn at night than there is during the day. This picture was taken at night. And what you're seeing there are mostly males because they're all crowded around females who are under the sand and they're trying to copulate with them. So if you've never seen this before and you live anywhere near New Jersey, you really ought to come down to Delaware Bay in May. It's an incredible, incredible site. It's one of the most incredible sites you can see in the world. Next. So our hypothesis that we were working on is, why would turnstones be so different? Why would sanderlings, yeah, you might understand because they may be feeding on the coast, but so the hypothesis that I've been working on, or does the surf wash away egg coating or exudate from laying females? So you have to remember that the females come up and they lay the eggs, 6-7 inches below the surface. They lay the eggs in a clutch. Most people who've been looking at eggs, including myself for years, and Nellie and Mike, a lot of the eggs are collected from the surface. But if you collect clutches of eggs, the clutches hold together, and there's obviously an exudate that the females lay when they lay the eggs that are parked together. So it's possible that the surf washes away this exudate, and it's also possible that the surf, because the eggs boil in the surf when they are up at the surface, and that there's a coating that might be washed out. And so there might be something turnstones are getting from the buried clutches that the other eggs cannot. Now, there's 2 things I need to tell you about this. One is that except for turnstones, the other shorebirds are not able to ever get clutches. They don't dig down. They get the eggs that are washed up in the surf. Once in a while, they get some eggs that turnstones have dug up because they come and they try to steal them from them. But basically, turnstones have access to the clutches, whereas the other shorebirds do not. do not. And so there could be something the turnstones are getting there. I can't answer the question because I had all the eggs ready to analyze and the lab got shut down. And so we're now back up and trying to finish doing this, but I can't give you the answer. But it's really an intriguing question because it comes down to whether or not they're actually have access to the coating on the eggs and the exudate, and they're getting something more from that. The reason for this hypothesis is that birds, and I've analyzed this, birds do secrete some heavy metals in eggshells, so that eggshells of birds contain a different suite of contaminants than the eggs themselves contain. So that's one way that female birds can get rid of some of the metals that they have. So it's possible that something like this is happening with them as well. The same thing happens with both pine snakes and turtle eggs, that there are different contaminants in the eggshells, even though they're soft for reptiles, than there is in the eggs. So that's what we're trying to look at in the lab this fall, as soon as we can get back to full operations, is whether or not that's where they're getting these extra contaminants. Acknowledgements are the people that I've worked for a very long time, and we've worked for a very long time. Chris is on the left. He's been my technician since 2002. I've seen him get married and have 3 kids. Brian, of course, you all know, and I grieve him deeply and was very, very saddened. And Nellie and I visited him only a very short time before he died, and we all miss him deeply. Susan Elbin, you all know for many long years, and Fred Lesser, I worked in Barnegat Bay with for many, many years, and he also recently passed away. So I have to keep my eye on the birds, which is the lower picture, a flock of knots on their way someplace else. And I thank everyone who's worked on the project over the years. We've been looking at metals for 40 years in some of these places. So I thank you very much.
Thanks, Joanna. We have time for one question. We've kind of run out of time, but let's take one question.
Sorry for the delay. I don't know what happened. I switched computers and it didn't seem to work.
I know what happened.
I'm just back. Kate, are there any questions actually?
I have a question, Joanna. That was so interesting, and that system I think is just such a really cool one. Most of everything that you're doing is dealing with metals. Have you heard anything about, or do you know whether or not these guys are potentially eating plastics that could be confused
yes.
with the eggs?
Brian and I collected some samples a while ago to look for those, and we sent them up. I'm going to ask Liz about some of the other stuff that she looked at, but we did send over, I think all our samples are sent, although I'm better check the freezer. But you know, Brian and I, we got so involved with a lot of his illness stuff that not everything necessarily made it everywhere.
All right, the next presenter is Kate. Are you ready to go, Kate?
Yeah, absolutely. See if
Kate is going to talk about amassing and use of the consumed plastics and parasites database for waterbird systems.
all right. Can you see that okay? Can you hear me?
Yes.
Excellent. All right. Thank you all. Of course, they put the parasitologist right at the end of the, before lunch. But I'm not going to be talking about anything particularly gross today. Today, instead, I'm going to be talking about this database. Basically, this is a growing data set that is based on a handful of studies that I've been involved with over the last decade dealing with metazoan parasites. So these are helminthic parasites, they're worms. And now we're also including consumed plastics as well. So today I'm going to talk a little bit about why I study parasites and why you might care about them if you don't already, how plastics fit in. I'll talk about the current state of the database and give just some very, very superficial information about what we can get from it right now, how it is growing, and then hopefully convince you to help us build on this a little bit more. So the first thing, why the heck study parasites? You don't need to do that. I do that. That's great. Most of the time when we're thinking about parasites, we're thinking about hookworms and other nematodes that cause serious health issues in humans. We have to give our pets prophylactics to keep them from getting infected. In general, we tend to think of parasites as big problems. However, parasites are parts of typical healthy ecosystems. In fact, the absence of parasites is more a cause for concern, because that suggests that in most cases there are some sort of trophic interactions that have broken down. And we understand in most systems that there is this coevolution that's occurring between parasites and their hosts. And when it comes down to it, in most bird hosts at least, parasites are not particularly pathogenic. They are really not causing a lot of morbidity or mortality within the birds. And that's because the majority of worms, at least, that infect the gastrointestinal tracts of birds are in their adult portion of their life stage. And they'll infect other types of organisms in their larval stages, but when they get into the bird is consumed a food item. They are an adult, they are reproducing sexually, and it is in their best interest to die of old age as opposed to killing their host. So if adult parasites in the gut of a host kill the bird that they're infecting, they effectively also commit suicide. So it's not really in their best interest to do that. So as a result, most of the parasites we see infecting birds are not particularly pathogenic. That's not the case when we see kind of novel infections going on, introductions of things, but in general, when I perform parasitological assessments on birds, the parasites themselves aren't causing much damage. Some really cool things that we can learn from parasites include what the heck the hosts are eating, right? So birds don't cook their food. We do, which is why we don't have that many parasites, and wildlife are plentiful with them. Understanding what parasites an organism has can tell us basically what it is that they're eating, and to some extent we can find out how much of what they're eating based on the community assemblages of parasites within them. So maybe we have lots of tapeworms and a few nematodes here and a couple of thorny-headed worms. That can tell us something about the components of the food web at which a bird is feeding. And in fact, we can even use parasites to group birds, and this is data from double-crested cormorants, and see that they're actually feeding in very particular ways. So here we have a kind of ordination plot where you have 5 different feeding types of cormorants where their parasite assemblages are different enough that we can distinguish them from one another. And that's pretty neat. We can do that with parasites. So doing parasite research, in my opinion, is incredibly cool. And it can help us to understand whether or not there are changes that are going on. Having these baseline data can tell us about shifts within the ecosystem or the food web. And that can be indicative as to whether or not there are changes within the abiotic environment, climate change, sea surface, things like that, as well as anthropogenic influences on our ecosystems like overfishing. There are certainly challenges in parasite ecology. There are not too many people that do it. And that's because actual identification is a hard thing to do. Ideally, we would love to use molecular techniques in order to identify everything. However, sample sizes and body sizes of these organisms tend to be very small. We have high rates of contamination and separating them from host tissues. And then a lot of the times there's DNA that gets sent out or RNA that gets sent out for sequencing, and they're not actually properly matched up with morphologies performed with microscopy. And as I mentioned, these are very small organisms. They have very small body parts that we use in order to identify them. And that requires some morphological expertise. You have to actually know what you're looking at. And this can be a challenge, not only because we're working from what were well labored endeavors for sure, but we still wind up with things like cryptic species. If we have a new host that has never really been assessed for parasites before, they're probably previously undescribed or new species. We also see different differences in terms of phenotypic plasticity, where we might have two very distinct organisms, but there's a lot of overlap in terms of their morphologies. And then we have issues associated with sample preservation and damage, because we have these kind of small body parts that we're dealing with. If ice crystals, if they're, say, frozen samples, if ice crystals form, they can actually move these organs around so, or damage them, so that there it adds challenges in terms of identification. Then that brings us to two different types of specimen preservation issues. The first one is with the hosts in the first place, right? So ideally, as a parasitologist, I would love to have a freshly dead bird to work from because everything is live and still moving around inside, and we can properly fix those guys. Many birds end up getting frozen, and that is a-okay too. And then we have some things that are kind of in between those. The actual parasites themselves also need to be properly preserved, and that in a lot of cases requires some decision making up front, because preservation for, say, molecular techniques is going to be completely different from what it would be for morphology, right? Freezing versus different types of preservatives. So those are some things that we need to really consider when we are trying to develop things like partnerships. So partnerships and planning is key when it comes to thinking about issues associated with preservation, getting the most and the best data out of as many birds as possible. But in most of the time, these end up being kind of opportunistic. So communication and really good record keeping is our next best bet. As I mentioned, opportunistic samples are something that I absolutely embrace. Some of the most interesting stuff that we're working on right now is from folks that are saying, I have 500 birds in a freezer that we're not doing anything with, and I'm about to get in trouble and have to throw them all away, right? And I've had many people over the years approach me with this issue, and to some extent, those are some very, very interesting collections that I'm absolutely willing to take on. We can still get good data with a single freeze, but freeze and thaw is something that should be avoided if possible. Okay, so where is it that plastics fit in? Plastics are for sure a hot topic. They're occurring in the same places the parasites are. They're in the gut of the water bird, right? And we're seeing plastics as we go through looking for parasites. And in some cases, the plastics are being directly consumed, but probably indirect consumption is more frequent. So for an example, we've got, a low trophic order alcids here, like auklets, that typically are going to eat things like copepods, right? These are plankton, and they could pretty easily confuse a nurdle, a small floating piece of plastic, for a copepod and eat that nurdle directly. And we do see those in the guts of these guys. But then the copepods themselves can become entangled or even consume bits of microplastic, microfibers in a lot of cases. And in fact, we do see that they are consuming these things. So that's an indirect way to be getting them into the food web. We also see this with higher trophic order birds as well, where maybe they're eating at the next level up from those, where yes, they too are eating copepods that could be confused. And we definitely see fishes that contain what we call shards. And in a lot of cases, those shards wind up in the stomachs of seabirds too. So to some extent, like what and how many plastics we're going to see are going to depend on the trophic level of that particular type of bird. Now, why is it that seabirds are eating these things in the first place? Well, certainly if it's indirect, they don't have much of a choice over it, but there are certainly some birds that are kind of dealing with this changing foraging situation, especially within the oceans. So in a lot of cases, they're searching for alternative prey items, and as a result, they end up trying plastics as they're trying new foods. And plastics themselves can be a really big problem by blocking the digestive tract. We've definitely observed that. It can cause mechanical damage to internal organs with sharp edges. And then the plastics themselves are made of chemicals, right? So they can leach those chemicals into the birds that consume them. They also grow biofilms on their surfaces that are particularly attractive to other chemicals and heavy metals. So in a lot of cases, by eating any piece of plastic, they're eating these little poison pills that can be both physically damaging, and they can also disrupt the endocrine and ultimately their reproductive success. So the sorts of data that are being collected for the database itself include things like host morphology and demography. So any sort of weight information, we're performing quantitative necropsies on everything. Any parasite information, who's there and how many, that sort of thing. And the same thing with plastics as we find them. And then as our collaborators also have been fantastic, if they have additional data that they are collecting that they're willing to include in the database, we have access to some of that. So for example, 2 of the projects included have performed bulk stable isotope projects. So those sorts of data could also be available. So some of the things that I'm interested in specifically is better understanding whether or not there are interactions of parasites and plastics in seabirds, knowing that there might be no interaction at all, but there could be a negative association where when we find lots of plastics, there are very few parasites. Alternatively, that as you see more of one, you also see more of the other. So ultimately, that's my goal. However, there's also a lot of other information we can get out of this. So the current state of the database is that there are 5 completed projects to date that are included in there. We have a little over a decade's worth of data. So the 5 studies, 2 of them were from my personal collection. So the first one's from my dissertation work on double-crested cormorants, where we only perform parasitology. And then the second one was from coastal birds from California. That was for my postdoc research, where we have 42 different species of hosts included, but that was parasitology only as well. Since then, we've added 3 additional data sets and groups of birds to this. The first one was cormorant and scaup diet studies from aquaculture facilities in Mississippi and Arkansas. These were master's projects from students at Mississippi State University in collaboration with USDA APHIS Wildlife Services. And there we have parasite and plastics data. We also have been collaborating with University of Alaska Anchorage, where we've got 27 different host species, and they've been performing the plastics assessments, or been able to do plastics assessments in the stomachs at least since 2009. And we have 2 good years worth of data of plastics and parasites, including microplastics from the intestines of these guys. And then we had a nice opportunistic opportunity looking at stranded northern gannets from 2017 that came from wildlife rehabilitation centers in Massachusetts. They're small sample size, but we were able to perform both parasitology and get some good plastics data on those. Sorry, my dog's barking. So just some very cursory preliminary data information that we can get out of this now. We can get data based on individual systems. So we have, sorry guys, hang on one second. I'm gonna mute myself for a second. How embarrassing. Sorry, somebody was at my door. Wonderful. So we can get some both system specific data. So we have different locations where we've got these guys from, but we could also look at host specific data because there are certain species that we have going across our different systems. So some examples. So these are parasite abundance data from the general studies that we've been looking at, and we can compare those sorts of things. We can also compare what's going on with plastics, knowing that not all of these studies have incorporated plastics at this point. We can also, these are heat maps, look at differences across the different species that we've got from the different studies. So these are the data from California, where we've got all sorts of different awesome stuff going on the x-axis, and we can look at the frequencies of different parasite infections for these. And again, for the California data, we only have parasite information, but you know, from the aquaculture assessments, we have both parasite and plastic data that we can compare. And we can do the same thing at this point with our species that were coming from Alaska. And I will mention, so as far as species numbers for this data set, 62 species so far have been included where we've done parasitology. 30 different species have been processed for plastics, and then 21 species have been processed for both parasites and plastics. We can also do those direct comparisons like I am really interested in doing in terms of what's going on with parasites and plastics. Here we have prevalence. So this is the number of the frequency that we're seeing parasites or plastics occurring within the guts of individual hosts. And we see there appears to be a pretty decent negative trend. But when we start breaking it down by system, it appears at least that the seabirds from Alaska are really driving this trend. We don't see it in the cormorants or the scaup, and we really didn't see it in the northern gannets either. So at this point, I'm just going to kind of show you a little video here on some new projects that are added or getting added to this. So we're processing now northern fulmar that have been collected by Alaska NOAA Fisheries in their bycatch program. And on the left here, you have a video of like a typical food item, a piece of tissue that a bird has consumed. And on the right, this is a piece of some sort of plastic mesh that has all sorts of nasty tissue stuck to it, but it's not actual food items, right? This is something that we found in the stomach. And then we have another exciting project working with window-struck birds, non-water birds in this case, in partnership with New Jersey Audubon. So these are the sorts of projects that we're trying to incorporate into this, and we're always looking for more. So my kind of take home at this point is, please consider contacting me if you've got something to contribute to this data set. If you have birds in a freezer, consider donating them to our group. It does take a little while to get through these, but the more projects that we have lined up, the better. If they're frozen in good condition, that is fantastic. If they were rotten, if there are maggots on them, if they made you gag, they'll make me gag, and I don't really want them. Okay, because probably the parasites have all degraded at that point, and they're not really going to be useful when it comes to that sort of stuff. If you have any identifying information associated with them, that is wonderful as well. I just really want to take advantage of existing collections because they're out there, and taking increasing lethal sampling and stuff like that just to perform parasitology and plastics work, well, I think it's certainly worthwhile. I also appreciate that a lot of you out there have access to potential samples that could be contributed to this. So I will wrap it up at that. Thank you so much for your patience with my barking dog and people at my door. But I will take questions if we have a couple of minutes for that.
Thank you, Kate. We don't actually have time, so I wanted to thank you, and I wanted to thank all the participants in this session. But since this is the last talk, I'm going to stop the recording, but I'll be happy to leave it on. And people can, you can ask questions and talk. Anybody that wants to hang out and talk and ask questions.
Thanks,
I'll
Kelly.
be here. Bye.